Namaste everyone. In this problem we'll be solving this problem on friction, which is on the Moodle. So let's go ahead. So we have a block here placed somewhat like this, and on this block there is a force acting from this side. Now look carefully at the question, what is being asked, and you can see here that more data is given here than what is required. So we are supposed to find the minimum force P required to keep block in motion. That means this is a problem wherein kinetic motion is already happening. So we should not take the coefficient of static friction. We should be considering the coefficient of kinetic friction. Now we know the weight of the object that is acting here is 222.7 newtons. That will result in a normal reaction here. Let's call it as N. And because the impending motion is towards the right, the friction force will try to avoid that motion and hence will act towards left. This friction force will be mu k times N because the motion is already happening. The motion is already happening. It's not just impending motion, it's actual motion. So we have to consider it as a kinetic or dynamic situation. That's the reason we are taking mu k instead of mu s. So let's go ahead and find the minimum force P. So that minimum force P will be equal and opposite to the friction force. So if you find friction force, we find P. Let's go ahead. So there is a downward force and there is an upward force. So when you take sigma of P, the upward force N minus 222.7, that total has to be equal to 0. And hence N value will be equal to 222.7 newtons. Coming to the horizontal summation, we have the P force which is acting right side and mu kn that is acting towards left. Total has to be 0. P value is not known. Mu k value in the question has been given as 0.17. N value we just now calculated. So let's go ahead and calculate it. So here I have my calculator, 0.17 times 222.7. So that's the result we want. So that is 37.86 newtons. So we just have to round it off to the nearest two values. Let's feed this value into our question, that is 7.86, and when we submit, it will show that yes, indeed the question is right, and you can see there is no error whatsoever in the value that we calculated and the value that is over here. That's it for this video. In the next one we'll take another problem.